Hi, everybody. Thanks for watching. Here's a good set of challenging problems that kind of spanned the content that we covered over a few weeks with congruent triangles and CP/CTC. So the first one we've done a lot of practice on. We need to set up a system of equations. The two triangles are congruent to each other, so we need to make sure that we understand what matches up with what. So angle QPR, an expression for that is given, and angle TPS, an expression for that is given as well. We didn't even need to know that the triangles were congruent in order to know that those angles are congruent because they're vertical angles. So let's start by setting those expressions equal to each other. There's two variables, so I know that I'm going to need two equations. So here's the first one. I'm going to organize it really quickly, and then we'll move on to the second one. I can just move this 5x over to the other side. And then I'll have 2x plus 3y equals 29. And then that equation will be organized. The other expressions that we were given were for segments QP and PT. I'm going to check the names of the triangles and make sure that those segments are corresponding segments from those congruent triangles, and they are. The first two letters are PQ and PT. So those two segments do correspond with each other. So I can set those expressions equal to each other as well. 4x minus 2y minus 11 equals 2x plus 3y minus 6. So I'm going to start by moving the x's and the y's over so that they're on the same side of the equal sign. So I have 2x minus 5y. And then I don't really want that minus 11 there either. I want to combine that with the other constant. So I'm going to go plus 11. Negative 6 plus 11 is 5. So that's my other equation. And the good news is I see that when I stack these two equations on top of each other, it's going to be pretty straightforward to eliminate the x's. 2x plus 3y equals 29. 2x minus 5y equals 5. I can just take that one of the equations and multiply it by -1, and then I'll have a 2x and a minus 2x. So I'm going to do that in a really quick and efficient way. I'm just going to take the second equation and change all the signs. So if I multiplied 2 by -1, I'd get -2. If I multiplied -5 by -1, I'd get +5. And if I multiply 5 by -1, I'd get -5. And now I can add my equations together. So the x's get eliminated, and I get 8y equals 29 minus 5, which is 24. And 24 divided by 8 is 3. And then I can pick one of my equations that has a box around it, whichever one looks the easiest. I kind of like to pick one where everything's positive. And substitute the 3 back in for y and solve for x. So 2x plus 3y. So 2x plus 3 times 3, which is 9, equals 29. And I can already tell that this is going to work out nicely as well. 2x equals 20, and 20 divided by 2 is 10. So then, of course, we ask you to substitute that back in and find some other stuff. So it says to find QT, which is this segment right here, which is what you get when you combine QP and PT. So why don't I substitute x is 10 and y is 3 back in? I really only need to do one of them because they should be equivalent to each other since those segments were congruent. So I'm going to do PT. 2 times 10 is 20. 3 times 3 is 9. So 29 minus 6 is 23. So I know that QP should be 23 as well, which means QT should be 46. And then let's see what angle measure I'm going to find. Angle RPT. So this one's kind of interesting. It is the supplement of the angles that I gave you the expressions for. So we can plug it in. X is 10, Y is 3. We can substitute that either back into QPR or into TPS and then just find the supplement of that angle measure. I'm going to pick TPS. That looks like a quicker one to calculate because I only have to substitute in X. So 5 times 10 is 50 plus 29 is 79 degrees. So the measure of angle RPT is just 180 minus 79, which is 101 degrees. All right, now let's move on to more of a proof problem. So I didn't ask you to organize this one in a 2-column proof. If I did, it would actually be a pretty long proof. I just asked you to justify your steps. So I'm going to start by marking up my diagram. So SK is perpendicular to PT, so I'm going to make a right angle box. PW is perpendicular to ST, so I'm going to make a right angle box. I could have done more right angle boxes than that, but I wanted to stick with the right angles that were actually in the triangles. And then RK and RW are congruent. They don't look like they are, but if it says that they are, then they are. And I'm out of givens, but I do have some vertical angles that I could use. So I could conclude that triangle SRW is congruent to triangle PRK by angle side angle. Well, how does that help us? Because we're trying to prove the triangle STP is isosceles, and definitely ST and PT, those sides are not in the little triangles that we proved congruent. And the base angles are not in those little triangles either. So the triangle is this one, and I would want the whole angle PST is congruent to the whole angle SPT. So we're not ready yet. So we actually want to move on and see if there's any other triangles that we could prove congruent as well. So I need to steal some stuff by CPCTC. So I could use the fact that SW and PK are also congruent. So SW is congruent to PK by CPCTC. And I might actually want to steal one other thing. I might want to steal the other side as well. So PR is also congruent to SR. By CPCTC. All right, that might not seem helpful, but the reason why it is I can add these two segments together to say that that whole segment is congruent to this whole segment. And then now we also have SW and PK congruent. As well, I highlighted those the wrong color. SW and PK congruent as well. And then SP is congruent to itself by the reflexive property. So that segment's in both. Triangles. PS is congruent to PS by the reflexive property. So now we have those two big triangles are congruent. So triangle PSW is congruent to its overlapping triangle SPK by side, side, side. And the reason why that's helpful is because then I can say that angle PSW is congruent to angle SPW by CPCTC, and those are base angles of an isosceles triangle. So this is a good little math symbol to know. This means therefore, so I can say therefore triangle STP is isosceles because its base angles are congruent. So sometimes you need to prove one set of triangles just so that you can steal stuff from them in order to prove another set of triangles congruent in order to prove a conclusion. So that's what made that proof a tricky one. All right, let's take a look at this next one. I think I'm going to skip part B for now and just focus on part A. So it says angle E is 70 degrees. And JH and FH bisect the exterior angles. So JH bisects this angle. And FH bisects this one. I think what's tricky about this problem is we need some variables and stuff to make some expressions, but we're kind of missing a lot of variables in the problem. So when I don't know where to start, I just pick something and call it X. So we know that the angles in a triangle need to add up to 180. One of them 70, which leaves us with 110. So the two angles left over in the triangle need to add up to 110. So if I call one of them x, the other one is 110 minus x. All right, as far as finding some expressions for those angles that are bisected, one of them is the supplement of x. So that would just be 180 minus x. This one over here is a little trickier because it's the supplement of 110 minus x. So you have to make sure to use parentheses and subtract both things in the parentheses. So 180 minus 110 is 70, but then it's minus x, so it's 70 plus x is what we would have. So if I want an expression for each of those little bisected angles, I'd have to take the expression for that whole angle and divide it by 2. So I can simplify that a little bit. 180 divided by 2 is 90. And then x divided by 2, I'm just going to write that as 1/2 x. So then this one I'd have 70 divided by 2 is 35. X divided by 2 is 1/2 x. So now all of a sudden I do have expressions that I can use. So I think I'll put those in the little triangle inside. This is 90 minus 1/2 x. There's not a lot of room to squeeze this in. 35 plus 1/2 x. And we want to find h. So it seems like there's too many variables and stuff. Like, how would we do that? But look at what happens if I add up 90 minus 1/2 x and 35 plus 1/2 x. The x's actually cancel out, and I'm left with 125 degrees. So if I want to know the measure of angle h, I just need to know what's left from 180 if the two angles that I know add up to 125. So the measure of angle h is just 180 minus 125, which is 55 degrees. And then finally, this last problem is a good coordinate problem. So we have an equation that was given for CM. It would be helpful to know what the coordinates of M are, and we can find them because M lies on the x-axis. It's an x-intercept. Every time you have an x-intercept, what that means is that y is 0. This point is something, comma 0. So what I'm going to do is I'm going to take this equation. I'm going to plug in 0 for y and solve for x real quick. -4 equals 2x, and -4 divided by 2 is -2. So that means that that point is -2, 0. So I want to prove that triangle CMA is congruent to triangle CMB. So I need to use a shortcut. So I know that this dashed line segment is congruent to itself by the reflexive property, but it would also be helpful to know that M is a midpoint of AB. If I could prove that these two segments are congruent, that would be a good start as well. So why don't I do that by finding the midpoint of AB and checking to see if it's -2, 0. So remember, for a midpoint, I can just average the x's and then average the y's. -6 plus 2 is -4 divided by 2 is -2. 2 plus -2 is 0. 0 divided by anything is 0. And it is. So I am right that AM is congruent to MB. So we need something else because right now we have side, side. I could try to show that AC and BC are congruent to each other. That seems like it might be kind of complicated with the amount of math that we've learned so far this school year. But if I could show that these two angles are congruent to each other, I could use side angle side. They're sup, so they add up to 180. So if they're congruent to each other, they would have to each be 90-degree angles. So I'm going to find the slope of CM and the slope of AB and check and see if those two line segments are perpendicular to each other or not. So slope of CM, slope of AB. All right, the slope of CM is 0 minus 8 over -2 minus 2. -8 over -4, which is +2. What I'm hoping is the slope of AB is the opposite reciprocal of that, which is -1/2. So let's check and see. It does look like it's a negative slope, judging from the picture. So the slope of AB, I'm going to go -2 minus 2 over 2 minus negative 6, which is negative 4 over positive 8, which is negative 1/2. So therefore, CM is perpendicular to AB. Well, because their slopes are opposite reciprocals. So there we have it. So I have congruent right angles. I have congruent segments because of a midpoint, and I have the reflexive properties. So I can, in fact, conclude that triangle CMA is congruent to triangle CMB by side angle side. And I was able to use a bunch of the algebra that we learned this year in order to justify it. So let me know what questions you have and keep trying to challenge yourself with these tough problems. Bye.